Our planet is a living example of a delicate balance. A complex system that is constantly changing, constantly evolving, constantly adapting. How do these changes affect life on Earth? How does everyday life affect our planet? We have a great capability to absorb, interpret, and comprehend, and an urge to understand the world we live in. This is what defines us as human beings, what makes us who we are. With our technological advancements, we are now capable of exploring new worlds, new frontiers. We're searching for answers that may lie in front of us. Better yet, above us. The field phase of the experiment is about to begin. All the planning, sleepless nights, meetings, and hard work the team has invested in the mission are at stake. My name is Jasna Pittman, and I'm one of the many scientists working on the Airborne Tropical TRopopause Experiment.
It's very natural for humans to want to understand how the world around us works.
Why the atmosphere does what it does, it's like solving a puzzle. You just want to understand how it works.
We're trying to understand how humans are affecting the atmosphere.
Understanding how the stratosphere changes very much reflects how our climate is changing.
I think that the work that is done in atmospheric science is very important, but it's also a lot of fun. It's like the best job possible.
Well, NASA has been doing airborne science investigations for quite some time. Some of the earliest investigations we were doing was related to the early days of the Antarctic ozone hole.
In 2009, we started a new kind of program. It's called the Earth Venture Program. It's got 3 parts, and the first of those parts is what we call suborbital science. This is science done not using or not including a new satellite.
It's a solid by mark. 3, 2, 1,
With some of these newer missions, we have let the community come up with their own ideas, their own way of implementing the mission, what their own science requirements are, and they bring their measurements to the table.
And ATTREX had very good science, was very relevant to the kinds of questions we wanted answered, and its budget was reasonable and appropriate.
ATTREX is an airborne campaign to try to understand how stratospheric water vapor affects climate.
It causes perhaps maybe 15 to 20% of the warming that we've had in the past 15 or 20 years.
So it turns out that small changes in the humidity of the stratosphere are very important for climate and important for surface temperature. They're actually comparable to the importance of greenhouse gases that everybody knows about.
So for example, we know that if you go back 30 years, carbon dioxide was quite a bit less 30 years ago. Methane was less quite a few 30 years ago.
Nitrous oxide was less 30 years ago. So we know these gases are increasing with time.
Gases that affect the chemistry of the stratosphere, which is where the ozone layer exists that protects us from ultraviolet radiation.
So understanding the rate at which this stuff gets into the stratosphere and how it changes is extremely important to looking at the climate of the stratosphere and how the stratosphere climate affects the lower atmosphere.
So we really need to understand what controls the humidity of the stratosphere and actually be able to predict that in the future in order to improve the accuracy of our predictions of future climate change. And it turns out the most important place to go sample to understand that is the tropical upper troposphere, the top of the troposphere in the tropics. It's called the tropopause, which is actually a very high altitude, which is why we need a high altitude aircraft to study it.
So the tropical tropopause is at about 55,000 feet in the tropics. So if you go down to the equator, you have to go up quite high, above 50,000 feet. And the tropical tropopause is really important to the global atmosphere because most of the gases that get into the stratosphere, all the air that's circulating upward into the stratosphere, goes through this tropical tropopause region.
So that's basically a gateway to the stratosphere. The general circulation transports air upward in the tropics, goes into the stratosphere, and then is spread throughout the stratosphere and comes down at the higher latitudes in the polar region.
And this is what ATTREX is focused on, to look at that motion of air into the stratosphere and how the water is removed from that air as it rises upward.
We know a lot about it, but there are some puzzles about the details of how the clouds are formed and under what conditions they form. So that's probably the most important thing that we hope to gain from ATTREX.
ATTREX will address a number of really important issues. It'll give us a better understanding of exchange between the troposphere and the stratosphere and how that impacts atmospheric composition, how that affects the chemistry that goes on in the upper atmosphere, and in the longer term, how that will affect the climate.
And that will help us to understand as we go forward trying to figure out what to do about climate change to better predict it and make better decisions.
How does the interaction between the upper troposphere and the lower stratosphere affect us down below? How are we going to find out? We have the questions. Now we'll be searching for the answers.